Hello and welcome to a new episode of the BIMvoice podcast. Today's guest is Øystein Ulvestad. Øystein is working as a BIM developer at Sweco in Oslo, Norway, where he is responsible for research, development and quality of civil BIM models. Welcome, Øystein.
Thank you very much. It's a pleasure being invited.
So nice to have you here. Let's start with introducing yourself a little bit and telling us a little bit more.
Yeah, I studied in Trondheim at NTNU, where I have a master, finished in 2000, and then I've been working for several different companies, mainly with steel design actually, but the last 10 years or so I've done concrete bridges, and in the last 5 years or so we've been doing drawingless design, where we do bridges and they build them without us making drawings for them. It's all based on a BIM model.
This sounds really interesting, and we are going to learn. I'm going to ask you a little bit more things about this. What do you see as benefits doing this and skipping the drawings, just dropping the drawings? Do we have any benefits? Is this a reason that any other companies should try to do this?
It's a good question, and it's not obvious that it's all advantages. But I think what we want to achieve is higher understanding of the problems to be solved, better clash detection, faster revisions, and in the end, a cheaper and better quality product. There's a lot of aspects to it, but generally, I would say that so far we've proved that it's a lot more advantages than disadvantages. But of course we can discuss aspects of it because it's not all positive. If you want me to go in detail about the positive things first, maybe
you can start with negatives, because if I can say one thing about this, is definitely is going to be needed more time, because you need to work a little bit more. But of course, this disadvantage is going to offset itself during the life cycle of the project. Now you please go ahead with the advantages.
Yeah, I think one thing what you want to achieve is better quality and a cheaper project. But of course, when we do this as consultants, we've seen that, you know, for thousands of years you've been building things based on drawings, and that takes, well, say 1,000 hours, just to name a number. And then for about 10 years now we have had BIM models, 3D models, and you still make drawings, so the drawings are based on the 3D models. And then we've seen that the quality of our product, it gets higher. They make less mistakes at site, and the clients, in our case Statens vegvesen, the road authorities, they have seen change orders going down from about 19% to 8% when you change from 2D drawings to 2D drawings based on a BIM model. But the disadvantage for us as consultants is that we use a bit more time than we used to do when we first make a BIM model and then a 3D model. But the project as a whole saves quite a lot of money. Now we're at the third stage where we skip drawings altogether. So we build bridges or structures based on just the BIM model. And we still see that we use more time compared to just making drawings. But those change orders that was 8% is going down even further, so that the project overall is saving even more costs, but we as consultants are spending more. So a disadvantage for us is how do we cover our expenses that's getting higher. Another disadvantage is how do you, in a model, say in a drawing, if you remove something from a drawing, how do you communicate that? You can do that by making a cloud, for example. In a 3D model, if you remove something, how do you communicate that you've removed something? If you add something, it's quite obvious. If you remove something, it's harder to tell people that you've removed something. So just small practical things.
You use BIM Collab.
You can, but if the client uses another software, it's not always so easy.
Yeah, but I mean a tool, like we have the tools, right? We have the tools if you want to do that it makes this easy. Because otherwise, yes, it would be messy to miss completely the overview over this, what is happening there.
Yeah. We've solved it with adding a revision document that's sort of linked to the model, but there are several ways of doing it. Another disadvantage, let me see. Yeah, one thing on a drawing, say in our case, we have 200,000 rebars in the bridge we're doing now. If and say 98% of those rebars can be moved sideways a couple of centimeters without that being drastic but some of the rebars, they need to be positioned exactly where they are in the model. For example, helixes around anchors for post-tensioning, and communicating that in a model. What is flexible, what is not? That's a bit hard. That's harder than on a drawing. Also, quality control. When you do quality control of a drawing, you're controlling a principle. You're saying this plan view of a reinforcement is valid for 100 columns, while in a BIM model you need to control all 100 columns. So you need a very structured way of presenting your data so that it's easy to build and easy to control.
Yeah.
And let's see, what other disadvantages do we have? Yeah, I have to think about it a bit more, but there certainly are some hard parts about 3D modeling.
Yeah, definitely. But all in all, like I think if you get all these costs, extra costs, and all these challenges, like you just said, like it might require a better planning before you start doing it. So you know that you are going to need to model 2,000 columns and put them in a specific way, right? If you plan that before and not just model one and after that start moving them around, then it's going to be easier, right? So you need more time to plan, to be smarter, right? To brainstorm more at the start. But this should not be a problem, not for the customer, not for the consultant. Consultant will get to work more, and that is, it is how it is. But overall, the price of the project, it will go down a lot because consultant cost, it's very low compared on the entire project, right? What is 10% of the building of the project? It's not more than that, or
no, it's probably lower. So I agree that spending some more time on doing a good model that with all the advantages that gives you on the project life cycle, it definitely should be worth it.
Exactly. And I did not even take into account the quality of data or information the customer is getting. So if he's getting drawings, it's PDFs, it can be paper, I don't know, but it's still dummy data, right? If you get the model, then you can do so much more with it. You can use some softwares, you can write some softs, or you can hire somebody to read some data you are interested. So if you take this, and this is going to have a huge impact over the entire life cycle of the building, right? Because you are going to save lots of money because of this.
Yeah, in Norway, the road authorities have been very proactive in allowing BIM models for third-party control, and they also start demanding drawingless projects now. So I'm very impressed by the work they have been doing. And of course, when they demand it, then contractors and consultants need to follow, and that's normally not a problem. What we have not seen in Norway yet is BIM models used extensively for maintenance and operations. But as soon as the data is standardized and you get a library of quite a lot of models, I'm sure that will follow.
Yes.
And owning these models, I think, will be quite valuable in the future, because it will be with big data and you know, machines learning from old models.
Exactly.
Yeah, I think it will be a very powerful tool, owning these models.
Yeah, I completely agree with that, and I have no doubt this is very, very important. And like you said, something very important as well. Like let aside the cost and everything, but it's not. It's going to be much easier to build a project when you see the 3D model. All the involved parts, even if they don't have a specific background, it's going to be much easier for everybody. Like for people that work with economy or something else, it's going to be so easier to understand. And even for the designers and the constructors as well, right? It's so much difficult. Like when you have the drawings, like you need and build the image in your head, right? This is the way you are building everything, right? And following the instructions. But when you see the 3D model, there is no doubt how something should look like. And when you combine that with some instructions that you said that might be nice in some cases, that is difficult to model, then should be no problem in doing that.
Now that's what you're mentioning is definitely one of the huge advantages of BIM models, understanding scope of work, and there's no cheating when you do a 3D model. When you do drawings, you know, you can choose to draw an easy section, not the complicated section.
Of course.
Well, when you do a 3D model, you cannot cheat, because you need to solve all the clashes, and so if that's been solved, then the people building, if they wonder, they can inquire by pressing an object, and you get information about the number of rebars or whatever, and you can rotate your view. So we see that we nearly don't get any questions from site anymore. So that's a huge advantage. Another one is that cross-country work is a lot easier, because drawings are very country specific. A BIM model is a lot more universal. Revisions, it's a lot easier to, you get a faster update of your design when you export a new model and send it over to the contractor. You know that every builder at site has the new model. There's no one stuck with revision C when everyone else is on revision F or whatever.
Yeah.
Also, when you do 3D modeling, you get a design up and running that can be clash checked with other disciplines a lot easier, so that the cost of making mistakes get a lot lower, and your impact on design gets a lot higher, because your design is finished earlier. Yeah, another very, very important thing is parametric design. I don't know if I should I explain parametric design a bit, or yeah. Parametric design is setting up rules for a computer. For example, you need railing posts every second meter. And when you're gonna copy out railing post every second meter, if you're copying along a straight line, it will take an engineer a minute to do it. But if the road line is winding, or the bridge side is winding, it could take, you know, a day if the bridge is long, because everyone has to be copied and rotated, copied and rotated. With parametric design, you set up a rule saying place a post every second meter, and it will follow the side of the road. And if you change the side of the road or the side of the bridge, it takes the computer a second to update it, while you would spend a day doing it. And then you start building these rules so that for our latest project, Randselva, that just won the Tekla BIM award for best BIM project in the world. We managed to have maybe. Thank you very much. I'm very proud of the team that worked on this. And anyway, so we set up parametric design rules that basically design maybe 60% of the bridge. So this can be, if we had to do revisions, that could be set up very easily. And also, if you want to reuse these scripts on the next project, then say you could reuse maybe 40–50% of those scripts again, so that it's well, it will be a very efficient way of designing infrastructure in the future.
Yeah, it definitely is helping a lot. I see though some. I'm thinking about some disadvantages that I don't know how can you mitigate these ones. Like I definitely see the advantages, and it's a no-brainer to use it, especially when you modify something. When you modify something, it's going to save your life, because if you do it manually, it's just it will take way too long time, right? Especially on a big project. We don't talk about a very small project here, right? We talk about infrastructure. So it makes sense. What I'm worried about, or not worried, but I'm thinking like a challenge can be here, it's maintaining these scripts. And not only that, maintaining the people that are working. You become very reliant on the people who are working with this. Because let's say if the guy who used parametric design on this bridge moved forward to another company or something, and you want to use it again, right? And you don't have anybody that knows it in detail. So someone is going to need some time to learn, to see how it has been used, or maybe just start from scratch, right? So from this point of view, I don't, it's just a thought that just came to my mind. I don't know, like the softwares we have, you know, they have the same interface, right? If you can, like, not necessarily document, because you document too much about it, you end up maybe using more time than doing manually. So it's a tricky question, this. But I have like the least you can definitely be sure about this is that you are going to eliminate lots of errors, because of like you set the rules, and the algorithm is going to do exactly what you tell it to do, right? So if you don't have a problem with like if there is, you have more people, I think this might be a good measure to have more people in the company, work with the same kind of things, spread the knowledge, right? Don't be very reliant on a specific person. So you don't need to take it from scratch.
I totally agree. Because the reason you use parametric design is of course because your normal software is, you know, if it's Revit or Tekla or whatever you're using, they don't have the tools for these very, very advanced operations. So you need to make them yourself. But what we worked quite a lot with on Randselva was structuring these new scripts so that you could easily understand it, even though you had never worked with the project before. Because anyone who's seen a parametric script knows that it very easily looks like spaghetti. and you know, it will even be impossible for the people who made it to understand it, you know, a month after they made it. And the problem with these huge projects is that it takes 2 or 3 years to finish them. So you never get to spread the information or standardize the information before you start the next project.
Exactly.
And also in 2 or 3 years' time, there will be another technology hype with some new tools. So things, you know, like it's a pro and con, but technology is moving so fast, so it's hard to have time to standardize things.
Yeah, that's true. No, I don't think in this case the standardization can work, not for this. And another thing, very important thing as well, if you take the bridges, or no matter what you take, tunnels or anything else, but bridges, like it's so huge variation, right? Like you might have the script for this bridge, but next time you need another design of the bridge, right? A steel bridge or a wood bridge or something, or different model of it, right? So it's very specific to location. So you don't find two big bridges similar if you go around, right?
No, definitely. And that's also part of the trick, to sort of divide your scripts into subscripts that would work on several types of projects.
Yeah. Make it components, like with the web development, with React and everything. Like make components that you can reuse to other to more projects. Yeah, that would make sense. That would be smart, maybe.
But and then again, as you say, to spread the knowledge, that's always hard. And then we see in the old days you had engineers and you had technical drawers, and those were the sort of two important parts in the project. And then a period you had people modeling, like I've used the last 10 years doing. So I would know enough so I could take responsibility for the whole model and maybe also make some drawings. And now with this parametric programming, you see there's to be good at that, you cannot be good at parametric modeling and calculations. So you get very specific. You know, we have maybe 6 or 7 experts in Sweco, but they only know parametric modeling. They wouldn't know the other things. So the more advanced you get, of course, the more specific education you need.
Yeah, definitely. And yeah, of course, if you want to get good at something, you really need to specialize. But like coding, programming is becoming more and more prevalent as a required skill. Like I guess, like any kind of engineer in a few years is going to be required to know programming to a different degree. So I think, yeah, it's going to be easier if you have a good system of a very high level explanation of how you build your scripts and this. You can do it. You can definitely do it. And yeah, I don't think people change jobs too often, not in Norway at least, not in this branch, in this field, from my experience. So, but yeah, you cannot count on that. That is something, of course. But yeah, it's like if you go the other way, it's not good as well. If you just do manual, it's not possible. You will just waste time. So
I wish I had time to learn more about it myself, but you know, in a busy workday, it's hard to find the time. But when we started this Randselva project 2 years ago, I was presenting the team to the people that was doing calculations, and they were all 50s, 60s, maybe, very, very skilled experts on their field. And then the team I was presenting had an average age of maybe 27. And they were our experts, and the expert, you know, there were no one knowing this better in Europe than they did. But I could see the faces of the or the people calculating that they were a bit worried, were we really going to make this happen? And then 2 years later, we won the best, like the global awards. That was fantastic. But I I had my doubts myself if we could solve all the problems 2 years ago. But then, luckily, we found ways of doing it.
Yeah. Well, you learn on your way to something. If you don't challenge yourself, then you are going to do the same thing all over again. And the competition is going to do other things, right? So you learn a lot doing it. Like, this is what makes being an engineer nice, right? Like,
yeah, definitely.
If you want excitement and challenges, you can have it always, especially now with so much technology around us, right? That we don't use enough.
No. But one thing that I have not mentioned yet, but of course we can, like, we as consultants can make the model can be as good as it can be a fantastic model, but if you don't have good people at site that transforms its model into understandable pieces of information for the people at the site, it's worth nothing. And we've been very, very fortunate with on this project and with PNC that they have some very talented people transforming this into packages for the people at site. And also they use the BIM model to order reinforcement directly from IFC. So all bar bending lists are taken from the model. So to make the whole process a success, you need a contractor that takes this seriously and put the right people in it. And we've been very fortunate to have that on the projects I've been working on.
Yeah, that's very important, and it's really nice to have people forward thinking that are willing to take on new challenges. Regarding this, by the way, there is one thing that I used to like. I remember a previous guest on the podcast mentioned something like regarding the importance of the 3D models or BIM models, and if we really need them, or it's just like we are wasting time. And and I asked him if this is not the next step, then what is the next step? What should we do? And he told me that actually, why would we need? Maybe we might not even need this. If we would have robots that can just read the code, you don't need to have models. Models you have for people to see and understand them, right? So you go straight to the next level. But we are not there yet. We don't have robots on building sites that can just build everything from scratch. And with this, I go to the next point.
Can I just supply something? I think
Sure.
you're onto something very important, because whenever I have doubts myself whether this is this really the way we want to go, and is it the right way, I always think, and the next step is robotic building. And a robot, you would never feed a robot 2D drawings. That would be ludicrous. You need to feed it information, like digital information.
Exactly.
And so before you can have robots building for you, you need to get rid of drawings. And that tells me that this is the natural way forward. So what you're saying, the point you have is maybe the most important thing in why we should use BIM.
Yeah, thank you. It's nice to hear that, and I agree, because I had my doubts as well. Not if the BIM models are better than drawings. That is obvious. Like, if you take everything into account, the understanding and the savings you can have, and over the lifespan of the project, it's undoubtable, right? And now we have the numbers as well, because before it was just talk, but now there have been some projects, not only infrastructure, but like there have been many projects built in Norway without drawings, right? And now people see the real value in that. So there is no debate regarding this anymore, at least not in Norway. I don't perceive this anymore. So, but I still, technology-wise, we might not be so far away from moving to robots that are going to build, and you just feed them. They don't need the model, of course. They need like instructions. Like you write a script, you can write the script and the robot will execute it, right? Maybe at some point. But we are not there yet.
Yeah, but at least you would not, if you need a code for the robot, you would never write that on a piece of paper and print it and
No. You just write a script.
Yeah.
No, just write orders, right?
Yeah. So it needs to be digital in some way.
Yeah, but when I see other challenges regarding not specifically, this is not only about 3D models or BIM models. This is generally across the supply chain. I see this a very important point here. And I remember you said that something in the start regarding the clients not requiring, or they don't get, or the designers don't think too much about what is going to be used in the operation. And this is, I see this as very, very, very important. Like, for this to work much more effective, like right now, you delivered on this, let's say, for example, this project, you deliver documentation that the constructor built it, right? So, but they, at the same time, I see two problems here. At the first time, they did not use directly your product, your model. They modeled themselves another model. Am I right about that? Or is not this the standard procedure? The builder, the general contractor is modeling itself, its building?
In our case, they use our model.
Okay.
So they don't model things themselves. So all the objects that they use and model, and that would be we have modeled them, and we transfer this through IFC files to them.
Okay, then this is very good, because I remember talking with more people about this, and I understood that companies like general contractors or builders, they used to model their own models because the models the designers are modeling are not made for to be built, or are not taught. You don't consider too much this aspect, right? So from this perspective, I'm thinking it was so then you needed to tweak the project, like for to think about the constructability, right?
Yeah, again, we've been lucky because it's a total enterprise, this bridge. So
What is that? Sorry for interrupting.
No. The contractor PNC, they got the job, and they hired us so that we knew what kind of bridge was going to be built, and we knew who was going to build it, which means that our model can be custom made for their production methods and the kind of equipment they use. We have this is getting specific, but we have a moving scaffolding system, and there's a lot of the design. So every pore face is designed to fit their equipment. And if you are working on a project, say a bridge, and you don't know who's going to build it, everyone is going to have a chance to bid on the price of building this. Then you need to make things a lot more general, and then you would have to tweak the design before you could build afterwards. But on this project, we didn't have that. We knew who was going to build it, so we're designing what they want us to design.
Wow, amazing! I must say, congratulations for this. It's very important, and I'm going to tell you why soon. Because I heard like you save lots of money for the entire project as well, right? Because if you need to use time to remodel again, I'm not talking about a consultant or a designer perspective, but from a builder and constructor, right? If the builder needs a team to design to make them to model it themselves, then they are going to need to pay for that, right? And the client probably will get some part of that cost in the final product, right? So this is very important, and it's very important also for consultants to think about all these aspects and not think only about like, yeah, I want to build my virtual bridge that I'm going to have very nice in the 3D model, but it's going to be a very, very, I don't know how they are going to build it. It makes no sense. But this is what is normally happening, usually happening.
Yeah, and I think in some projects that's the way it has to be, and will have to be in the future as well. But then you at least you want to be able to connect every object to some kind of process code, so that you can quite easily price every aspect of building this bridge when you're bidding on it. And again, that's some work that we haven't done on this project, but I know quite a lot of the Norwegian companies are working on standardizing this, so that it would be easy for a contractor to get a BIM model and then put prices on the different aspects of it in a standardized way.
Wow, that sounds very good. That's a very good news.
Yeah. But how you then would, if you could reuse this, say, we in Sweco, if we build a bridge or a bridge model that someone's gonna bid on building, and then if they win it and want someone else to tweak the design for them, how do you avoid the whole model having been modeled again a second time? I don't have a good answer for you there, but that's of course a goal that you would reuse design.
Yeah, it makes sense. It makes sense to find solutions for this, and everything starts with the contract form. Contract form are very important.
Yeah, definitely.
Have you worked on any project with IPD, Integrated Project Delivery?
I'm not so familiar with the term, but at least like the last projects I've been working on with drawingless design is all we know who the contractor are, so we can so we know the method they're going to use to build it, and so we can use the products they want to use. We can model the dimensions they need for their tools. And I think that's a very good way of working with this kind of technology. Okay,
I'm not an expert with IPDs, but I know that integrated project delivery they are used in US, not a large scale. They think it's really nice, and I kind of contract, and I know they have been tried in Norway as well. So the main aspect of this is that everybody is involved in the process: the designer, the builder, and the client. So you have these meetings where everybody is involved, so you can spot and with misunderstandings from a very early phase, so you avoid misunderstandings later. So from this point of view, but yeah, regarding what you said, this is a very important aspect. We need to find better ways to clarify this, how is best, right? Because it's a big saving potential right there to avoid doing the same work twice.
Yeah, definitely. And also, if you can avoid making a new model when you do maintenance and operation, it's important.
This was the next thing I was willing to point, but this is not happening not because you don't want to do it. It's not happening because the customers don't have the knowledge or to require it. So I think the next step, this was what I was pointing out. Now we think how we design to be built, but we need to get to the point where we get the exchange information requirements from customers, that we know how we must design for maintenance and operation. Then we have BIM used at its full potential.
Yeah, definitely. And at least say if we were to make a operation and maintenance model of this latest bridge, it wouldn't be very hard. Like the attributes you need for operation and maintenance is quite different from what you need when you're building it. But attaching new attributes to every object, that's not very complicated. It's just a matter of knowing what's important to the people that's going to maintain it. But of course, that's dependent on Sweco doing that job, because if some other company with another software is doing it, then you lose a lot of the information.
Yeah.
So if you're transferring something from Tekla to Revit or vice versa, you would probably lose quite a lot of data. And I don't know quite how you could do that efficiently, but maybe you could use your IFC files to generate a new model.
Exactly, and not necessarily a model. This is what I'm thinking. Like they don't necessarily need a model. Not always. They might use the model they get for some things, like to see a door properties or something. But there might be more data that they could just get in a database. I don't know.
Yeah.
And just make some queries to get out what they need to look for. I don't know exactly how, but I think we really need to get over this formats and everything. So we are going somewhere with IFC, but we definitely need to get to a point where it doesn't matter what you use. Like we need to focus more on this kind of tools that makes the tool you are using redundant. Doesn't matter anymore what you are using. You just use something that connects to worlds, and you take the data you need. I think I've seen someone from Sweco. I don't remember his name, but he tries to use Speckle, which is this kind of interface that you can connect two different. I think he's trying to connect the modeling part with the structural analysis. So you get a very fluent workflow, taking only the data it is needed, because this is very important as well. So you might not need a civil engineer to do that, to design that. You might need a programmer to do that list, or I don't know, or someone else with other. But I'm thinking for a process that makes sense. When you buy a car, you want to have the options that you are interested in, right? It should be the same. Like you need heat or air conditioning because you want to be warmer or colder, right? So it should be the same here.
It's an interesting thought, because with parametric design, your geometry is based maybe in our case in Rhino, a program that generates geometry.
Yeah.
And then we sort of we lift it over to Tekla. So if you could manage to have your whole geometry in some kind of format, for example Rhino, then Tekla is sort of just a middle software to export IFC files. But if you're going to use your model for operation and maintenance later, then it would be software independent in another way. That would be good.
Yeah, exactly. But anything starts with from being aware about this, right? Right now, we don't have clients that require for this information because they don't. It's not anybody's fault. It's a learning process, right? But it makes sense. This would make the entire supply chain much more efficient.
Definitely.
And it would cost a lot less during the entire life cycle.
And you could maybe connect that geometry to a calculation program, as you mentioned.
Yeah.
But then the problem also is that what you need from a model is so different if you're calculating or if you're modeling for a third-party control or someone building, and for operation and maintenance, because pore stages doesn't really make any sense when you're doing operation and maintenance.
No.
Like, so how you divide your elements, sort of in the building stage of Randselva, we have over 100 pore faces, probably over 200 pore stages. But in operation and maintenance, you could see the concrete for the whole bridge as one unit, because probably you don't need data for a pore stage after it's been casted. And when we do railing, a railing post for us is not divided into screws and bolts, but maybe that's important when you do operation and maintenance. So that's a challenge.
Well, if I may interrupt you here, I see this as a very simple line in an exchange information requirement contract. Like, if the facility manager needs this, they need to specify it. It's so easy. And now we get more softwares and tools and we get ISO 19650, right? So you get good guidelines. You just need to start using them and start from somewhere. You said, public road administration and Bani Noor as well, Statsbygg as well. They are all trying to use more and more 9650 ISO standard to formulate better requirements. So you need to start from there. And we can try to guess what would be best for a facility operation way to design things. But this is would be not very efficient. Or we should just ask, like I said, if you have all the parts involved in the process from the start, and you have a meeting with the facility manager, or you have a chapter in the exchange information requirement document where they specify, I need this kind of information. That means that and that and that. So you don't need to guess. Like, you know how to do your job. You don't need to start being a facility manager. Just try to provide them the information they need. You might be able to do it yourself. You might be needed to hire a programmer. It might be necessary. Like, not this sounds very dumb actually, because I'm still amazed that we don't have, I still see engineering companies that don't have in-house programmers. This should be long time ago normal anyway. So I don't know what kind of people you would need for that, but the best to provide that, I had actually the last episode, facility manager, and the best would to talk to him and ask him exactly what do you need. Like, everything should start from there. How are you going to use this building? Describe it and tell me what you need, and then you provide it as a consultant.
Yeah, no, that's a two-way thing, of course, because many times they don't quite know what they need because they've never seen it. You got to show it to them before they believe it, sort of.
Yeah, but that's why these meetings are very important. That's why we need to be involved from the start, right? And have regular. That's why I see interconcurrent engineering is important, right? You definitely do have this kind of meetings on some projects, right?
Yeah. We these ICE meetings, we had them a lot in the start for this project, and also earlier projects I worked on. And the thing is, for us, we're delivering a product to the client. That's PNC, as I mentioned. And a good product is a product that understands their needs. And a bad product is it's making work hard for them. And I think we managed to tweak the design so that it fits their way of working, and also a very rewarding cooperation for us is that they get back to us and say, this would help us a lot if you could do this or that.
That's very valuable.
Yeah, definitely. And it heightens our level of competence, and it enriches the product in a way that's a lot more useful for them. And I think in contracts where you don't have that calibration, you lack, you're missing out on a lot of useful information.
Yeah, that's definitely a challenge, and I think that should be like that should be more of the responsibility of the client. Like they should find out the best way, the best type of contracts for their own interest, right? Of course, like you need to involve everybody. You can consult with anybody, right? But it's your interest, and not only to get built a thing, because that is very, very small part of the project. Like I said from previous conversation, I understood that you get around 20 to 30% of the entire life cycle of a project is going to cost you to build it. But then 70 or 80% in some cases you will spend during this year using and operating the facility, right? So this is another thing that is a shame that we focus, like customers, clients are focusing a little bit too much on the price to hire the cheapest price, and not thinking on the long run. But this is easy to understand because it's difficult for us to compute, to think so many years ahead, especially for infrastructures. Like many of them might not be live to see 20% of the lifespan of a building, of a project or something. So I don't know, but I think these are important topics and things that if we make better, everybody can thrive much better. Contractors thrive much better. You as a consultant are going to, like, even if you have a contractor or a builder that is going to require you more things to do, it for someone might be a little bit annoying, but in that way you secure a better delivery for them, right? And you learn to do things in a better way, or to think about their needs as well, not only about your needs. Because this is something else I seen before. Like, yeah, consultant will just design the building without thinking too much. I need to do my job. I finished. That's done. It's your job after that, right? So this is another. But everything comes down to the contracts. This is very important. So everything starts from there. But we are like a cycle that we are involved in these complexes, right? The client cannot grow without consultants or designers growing, or builders growing, because in this cycle we learn from each other, right? So
the good thing about Norway is that it's so small, so it's sort of spreading information and making all the companies work the same way would be easier than in a larger country. And the Norwegian government has been very, involved in involving the industry, and also I think concrete bridges is a very good way of starting this process, because it's not so many other disciplines involved, and there's often one company doing all disciplines, whether that being water or geotechnics or whatever. And in concrete bridges, you don't have all that many third-party products that you put in. I'm guessing in a commercial building you have hundreds of different companies that then have to use the same 3D model.
Yeah.
And maybe 10 companies adding information and models to it. On these concrete bridges, we have one company doing all the modeling and then another company extracting all the information. So it's thankful kind of a construction to make using BIM.
Yeah, that makes sense. It would be very difficult to start with something much more complex. But like from a mindset point of view, it's very important to look for improvements, to look for things. What can we do better? Because this has been too long since we are just fighting each other, maybe between disciplines, or consultants, and builders and clients. So requiring better information, providing better information, building better products is going to eliminate lots of this, right? But it's so much improvement only when you talk. when you involve everybody and don't see anybody as your counterparty or something, right? And you see the other party as a team, like we need to succeed. All of us need to succeed for this, right? So that's why IPD contracts are interesting, because it incentivizes everybody to make the best out of it, because the quicker you finish the project, the better you do it, you get more money in profits. So that is something that, of course, is not easy to change overnight, but yeah, it might not be perfect, but it might be something to look out for.
Yeah, I agree. And on working together, when you sort of intermingle processes, getting a good team going and a team spirit going, that's a lot easier when you cooperate to make a good product, whether that be a BIM model or the structure itself. And I don't know if we've just been very lucky on Randselva, but it's been a pleasure working with both people calculating and people building it, and very few conflicts overall. And it's COVID time, and there's of course challenges, but I think like having respect for each other's knowledge and work is a lot easier to get the feel for the complexity of other people's tasks when you work together on these kind of projects.
Yeah, that's definitely true. What is your interpretation of building information modeling? Because I did not ask you in the start.
Yeah, I think first you have to model objects, 3D objects with the volume and not just lines. And once you start attaching some kind of attributes to those objects, that's BIM to me. So whatever you model, it's not important, but if you click on an object, you need some kind of structured data popping up.
Yeah. So you need to connect the information to the object you are modeling. Otherwise, they are just placeholders.
Yeah, and in the old days, it would just be lines sort of symbolizing a 3D object.
Regarding BIM adoption, you said that in Norway it's easier because it's a smaller country and it's easier for people to come along and join their forces to this. What would be a part of what I said regarding the supply chain? Do you see any other challenges in this? Like what is still holding us back to get us to the next level, to become more productive and working better together?
Yeah, I guess the first thing is the amount of projects. Like to have good decisions, you need some data to base that decisions on. And since we've done so few projects, say maybe guessing, there's maybe 100+ structures in Norway that's been built without drawings, but still the road authorities don't have much data suggesting if we make fewer mistakes and if we spend less money. And of course, the contractors doesn't really want to give the information or share the information, but having good data to compare this way of working with other ways of working, that would be very, very important. And I haven't seen this data yet.
Yeah, exactly. You touch wasp nests with this. This is a huge problem because in a ideal BIM world, people should collaborate. Like if you will have the right information in the BIM model only if you have everybody sharing the information, right? But to become better at this, to make it the best out of it, we need to work together. But not, to work together, you need to talk with each other, right? And this is a huge problem. Yes, we don't share enough data. We don't share anything. Like we keep everything inside. Like, do you have any ideas? How might we get this? How could we become better at this? How would what would do us make us to make this easier?
Maybe I guess if the road authorities or the project clients, if they demanded data on this, I don't know if you could sort of contractually force people to share, and maybe that would be an idea. So data on that can support your decisions, that's important. And then standardizing things, whether that be colors in the models or information tag symbols, or what kind of, like, say you need to link your model to some external document, where should that be saved? What kind of format should it be? So that could be a thing.
Yeah, I think this is something that comes with ISO 19650. So these are things that are very prominently described there, like you should have in a exchange information requirement document, right? So this is definitely like on the client's part. From your experience, do you know, are the clients, like for example, the public road administration, are they very aware? Do they? I think they try with Bane NOR together on the Ringerix Bane project to have this kind of document. But I don't know outside of this. Do you hear around yourself? Let's forget about customers, but generally around yourself, do you hear any noise about ISO 9650? This ISO BIM standard that became international after being published in United Kingdom.
I'm not very familiar with the standard myself, so I cannot really answer that in a good way. But I know Bane NOR, the railroad authorities in Norway, they're trying to standardize attributes, BIM attributes, and so are the road authorities, Statens vegvesen and Vegdirektoratet, and they're involving us as consultants in that work. And it's a tricky question because you want to standardize attributes. So you know, a door is always called the door, and you can find attributes on the door there and there. But then you end up with 10,000 attributes. And is the door, is that a unit, or is the handle also a unit, or like how do you want to divide it that way? So
maybe employing object-oriented programming paradigm, like think about an object and smaller objects, and then you have families and sub-objects or subfamilies and such. I don't know.
Yeah, but then your model gets very, very heavy if you start adding levels and details. I mean, Randselva, we have at least 250,000 objects in it, and if you attach 1,000 attributes to every object, then you have, you know, millions and millions of attributes. And then I guess the most important thing about BIM is giving the right information to the right people at the right time. And if you want to do that, then you need to rigidly control the data. So if you have too much data, it's hard to quality control it, and it's hard to find it. So on the Randselva bridge, we have 12 standard attributes per object and 10 open ones that you can sort of add whatever information you want. And even that is hard to structure. So I think it's like limiting your attributes to what stage you're in. Yeah, it's very important. Yeah, so I guess it's not answering your question at all, but at least it's
no, it's perfectly fine. It's perfectly fine. The 9650, it's quite new for many, so it's not a shame not being updated with it. I know about it, but to a very high level. I don't know details, too much details. But all you mentioned about like these requirements are very, very well described how to do it using this standard. So this is going to become definitely a new norm. And I think Bane NOR and Statens vegvesen, they are the requirements they have made for this project for Ringerix Bane. they have used ISO 19650 as the backbone of this document. So the document is based on this standard. And not only that, it goes much more into detail, and it requires you to have to define a common data environment that you are going to use. So you have all the data in the same thing, in the same place. Everybody have access to everything. So yeah, we might have an answer right there. Like we definitely need more customers or clients to become more familiar with ISO 9650 and try to apply it to a degree. Start using it, because it's very it's a very concrete thing that you can, yeah, I want to try this. I don't want to think to something more advanced or something, but it's a very good way to create better contracts and better requirements.
I think there's two ways of it. It's good with a standard saying how you should do things, but in uncharted territory, like these BIM projects are, you want to take baby steps, and you want to try and fail fast and then scale up. And sometimes these standards, with the best intention, they give guidelines, and they're not really all that feasible to use in the projects, because either they don't take account new technology, or they have there's many things that can go wrong. So it's, at least from Vegdirektoratet, when they try to standardize things, they give them as advice first, and if it seems to work, then it becomes a standard. And what you're standardizing at the time is sort of it doesn't have to be big things. It can be, at the moment we're working on a list of attributes curtains. So sort of one thing is attributes, and what kind of curtain should that attribute be connected to?
Yeah.
And it's a low-hanging fruit, and it's not very complicated, but it still takes quite a lot of trying and failing to get it right.
Yeah, no, I completely agree regarding standards. I'm not a fanatic fan about standards myself, but even though I'm quite critical to them, I think they are a good starting point. And of course, that doesn't mean that you need to try to spit out just copy paste the entire standard in your contract and require without understanding. First, you need to start learn, like you said, baby steps. Try to understand as much as possible, and start with specific requirements and go from there, right? Like it might be a good starting point compared to not having anything, and yeah, just trying to do the things you are in the way you are comfortable doing the things with, right? So from this perspective, I think it's important, and because right now they can say customers, right? We don't know how should I know, but you have these guidelines here, and I don't think they are very specific. Like, I need you require me this, and this. No, I think you get to ask yourself more questions and define your own terms as well. What you want to include, and leave it a little bit more open. You need to be like okay, the colors you can specify. I want this color. That's easy, right? But if you need more variation with different aspects, then you might just leave some room for movement there, right? But to start from somewhere, like and most importantly, to start understanding why I'm doing this, because the standard has behind this reasoning, like how to get all the parts more evolved, and how to get the best product, and how to get the best operation and maintenance afterwards. So of course, there is nothing perfect.
No. And another thing with BIM models that I think could be improved is sort of readability of the model. Like the best computer games, you know, they're very good at intuitively making you understand what to do.
Yeah.
And you know, the big software companies or like an iPad, you see babies using iPads because it's intuitive.
Exactly.
And you know, a person with well, 20 years of experience do not know how to use a BIM model because it's engineers making it, and we're good at engineering, but we're not good at you know, what do you say? Well,
Communicating or yeah.
So yeah, no, I agree, and that's something we try to spend quite a lot of time with the Landselva, and I'm not the one to answer if we succeeded or not, but you know, like making your colors in a model in a way that you understand intuitively what's important and what's not, and also where you can find your information without looking around too much. And I think that's a part that needs to be improved as well. If you could standardize that, and that should not be very hard to standardize, then you would do the whole BIM community a huge favor.
Yeah, I completely agree with that. Well, Øystein, if someone wants to contact you and ask you a question, or get in contact with you, how he or she should do it?
The easiest thing is LinkedIn, I guess. My name is Øystein Ulvestad. So I think if you spell Oystein.
Oh, don't worry about that. I'll put it in the
of course,
as a link in the show notes.
I'm forgetting I'm forgetting we're digital. Yeah, LinkedIn profile. I guess that's the easiest. And there you could see some examples of the work we've been doing lately as well. So contact me and write me a message there. Yeah, I guess that's the easiest way. Okay,
that's awesome. Well, thank you, Øystein, for taking the time to coming along. And
it's been a pleasure. I love this conversation.